Alright, so now that we've done a review of transformations of functions and we now know how to describe what transformations have happened, let's do an actual example, and we can also use the mapping rule to help us sketch our new transformed function. So let's do an example problem. If f of x equals x squared, what I would like you to do is describe the transformation and sketch. If our transformed function is y equals negative f of 1 over 4 x plus 4 plus 5. All right, so the question that we have here is, if f of x equals x squared, describe the transformation and sketch y equals negative f of 1 over 4 x plus 4 plus 5. So let's describe our transformation first. And what I like to do is I like to compare our transformed form equation, which is y equals a f of k x minus d close bracket plus c. So here all you need to do is figure out, okay, what is your a, k, d, and c value by matching your two equations up. So here a equals negative 1. And when a equals negative 1, that means we have a reflection in the x-axis. All right, let's take a look at our k value. K equals 1 over 4, right? All I'm really doing is I'm kind of like matching it up. I'm comparing these two equations, figuring out, okay, what is our a value, our k value, and so on. So k equals 1 over 4. That is a horizontal, and remember, this is a tricky one. It's a horizontal stretch, or not a tricky one, you just have to kind of remember the pattern. It's a horizontal stretch by a factor of not 1 over 4, but of 4. So you have to flip your 1 over 4. So it's a horizontal stretch by a factor of 4, right? How I remember it is, okay, if I'm flipping this 1 over 4, it becomes 4. Whenever you multiply something by 4, it's going to become bigger. So therefore, it has to be a horizontal stretch. Okay, let's take a look at D. Okay, so here, just be careful. You would think D equals positive 4. But remember, this has to match up, x plus 4 has to match up with x minus d. My original is minus x minus d, but here in our given transformed equation, it's x plus 4. Where did the plus come from? It must have meant that this is x minus negative 4. So therefore, your d value actually is negative 4. When d is a negative number, that means we're going to go to the left, horizontal translation to the left, 4 units. And lastly, we have our c value, and c equals positive 5. If it's positive, that means we're going to go up, and that's up 5 units. From here, you could just follow your descriptions of your transformations and graph out and sketch out your transformed functions. You can definitely do that. Or you can use the mapping rule. So let's take a look at the mapping rule. Let's practice using our mapping rule. Okay, so our mapping rule. And mapping rule you can use for any transformed function, which is nice if you kind of like to use an equation. So the mapping rule, you're going to take your original parent function and its original coordinates, so your x and your y. You're going to apply your coordinates, these original coordinates, to the mapping rule to this equation, which is x over k plus d, and that is your new x value. And then your new y value is going to be ay plus c. So let's actually write out what our k or d values. Let's plug these numbers in. We have x over our k, so just take a look back here. Okay, so our k is 1 over 4. So x over 1 over 4 plus d, which is negative 4. I'm just going to change that, minus 4. And then ay plus c, our a value is negative 1 times y plus c, which is 5. Right? I'm just looking at all my values here. I'm going to simplify this because I have this x over 1 over 4. If it's x over 1 over 4, right? This is x divide 1 over 4. How do you divide fractions? You need to multiply it by the reciprocal, so you get 4x. It's just easier for me to look at it like that. So 4x minus 4, and then negative 1 times y plus 5. And that is your mapping rule equation. So you can use this to figure out your new coordinates. Okay, so let's start figuring out our new coordinates then. Now, remember, what is our parent function again? Okay, our parent function is this quadratic equation of f of x equals x squared. So I'm going to do y equals x squared, and it's going to be transformed into this new equation. Y equals negative f of 1 over 4. I'm just rewriting my equation. X plus 4 plus 5. Okay, so you just need to choose a few parent coordinates. And this is where you do need to remember what your parent function looks like. So here we have y equals x squared. That's your parabola, right? And it looks something like this. Excuse my drawing. And here we have 0, 0. We have 1 and 1, 2 and 4. Here, this is negative 1 and 1. This is negative 2 and 4. So you just need to choose a few coordinates. I'm going to choose these 5. Let's go. Let's do negative 2, 4, negative 1, 1, 0, 0, 1 and 1, and 2 and 4. And from here, just use your mapping rule equation, right? So my mapping rule equation is 4x minus 4, right? So I'm going to do 4, and then instead of x, right, my x is negative 2. You're just going to use your original x and y coordinates and plug them into your mapping rule equation. So if 4 times negative 2 minus 4, and then I have, take a look at your mapping rule, that's negative 1 times y plus 5, so that's going to be negative 1 times, for y you're going to plug in 4 plus 5. And you're going to do the same thing. So just keep doing that, but your x and your y's, you're just going to use your parent coordinates, right? So it's going to be 4x. This will be negative 1 instead of x, right? We're just plugging in negative 1 in for x, minus 4, negative 1y, our y here is 1, plus 5. Keep going, so 4x 4 times 0, negative 1 times y, our y here is 0. This one, 4 times x, which is 1, minus 4, negative 1 times y, which is 1, plus 5, 4 times 2, negative 4, and then negative 1 times 4 plus 5. Right, so all I did here was I used my mapping rule equation. Right, this, I just plugged everything in here. So that was 4, right? If we want to rewrite our mapping rule, so it might be easier for you to see, that was 4x minus 4, negative 1y plus 5, right? My x values, I just plug them in from my parent coordinates. My y value, let's do orange, right? My y value, I plug those in. Oh, sorry, I think the color doesn't really work very well, right? I plugged in these y values into y, right? So that's all you have to do. That's the good thing with the mapping rule. Kind of makes your life a bit easier. And then just calculate that. So then we get negative 12 and positive 1, negative 8, yeah. Negative 8 and 4, negative 4, 5. Hopefully I've calculated this correctly. 0 and 4. Please let me know in the comments if I did not. And there you go. These are your new coordinates. Woohoo! And then just take those coordinates and then graph it out. So this graph is obviously not going to be to scale. So don't judge me on my drawing. But we do know it should look like a parabola. Negative 4, let's say negative 4 is there, and this is 5. Let's say 0 and 4. And then let's say this is 4 and 1. And then your transformed graph is this. Oops, sorry. And there you go. Right, and that kind of well, not kind of, it should match your descriptions of what's happened to your transformed equation, right? There was a reflection in the x-axis, right? I'll quickly draw out our parent function, right? Your parent function should look something like this. Y equals x squared, right? So there was a reflection in the x-axis, yep, right? Horizontal stretch, right? Our graph has gotten wider. It's been stretched horizontally. It's moved left 4 units and it's moved up 5 units. And there you go. All right, so it's always good to, once you've gotten your new coordinates, right, you plot them, you sketch it, and then just double check with your descriptions of your transformations. Do they match up? Hope this helps, and I'll see you later.